Welcome to this video on prime factorization. Today, we'll learn how to break down numbers into their prime factors, which is like finding the DNA of a number. We'll go through 3 different examples and discuss which numbers can and cannot be prime factorized. Before we dive in, let's remember what prime numbers are. A prime number is a natural number greater than one that cannot be formed by multiplying 2 smaller natural numbers. Examples of prime numbers include 2, 3, 5, 7, 11, and so on. The number 1 is not considered a prime number. Now, let's understand what prime factorization is. Prime factorization is the process of breaking down a composite number into a product of prime numbers. For example, the prime factorization of 12 is 2 times 2 times 3, or 2 squared times 3. Let's start with our first example. Find the prime factorization of 36. When factorizing a number, I like to start by dividing by the smallest prime number, which is 2. 36 divided by 2 equals 18. 18 divided by 2 equals 9. 9 divided by 3 equals 3. 3 divided by 3 equals 1. So the prime factorization of 36 is 2 times 2 times 3 times 3, which can be written as 2 squared times 3 squared. Another way to find the prime factorization is using a factor tree. We start with the number 36 and split it into any 2 factors, 6 and 6. Then we continue factoring each composite number until we reach prime numbers. 6 can be factored as 2 times 3. So again, we get 36 equals 2 times 2 times 3 times 3, or 2 squared times 3 squared. For our second example, let's try to find the prime factorization of 23. First, we try to divide 23 by the smallest prime number, 2. 23 divided by 2 gives us 11 with a remainder of 1, so 2 is not a factor of 23. Next, we try dividing by 3. 23 divided by 3 gives us 7 with a remainder of 2, so 3 is not a factor. We continue checking with 5 and 7, but none of them divides 23 evenly. Since 23 is only divisible by 1 and itself, it is a prime number. The prime factorization of 23 is simply 23 itself. For our third example, let's find the prime factorization of 84. We'll start with the smallest prime number again. 84 divided by 2 equals 42. 42 divided by 2 equals 21. 21 divided by 3 equals 7. 7 divided by 7 equals 1. So the prime factorization of 84 is 2 times 2 times 3 times 7, which can be written as 2 squared times 3 times 7. Now, let's discuss which numbers can and cannot be prime factorized. All positive integers greater than 1 can be uniquely expressed as a product of prime numbers. This is known as the fundamental theorem of arithmetic. However, the following numbers cannot be prime factorized. 1. The number 1, it's neither prime nor composite and has no prime factors. 2. Negative numbers. Prime factorization is defined only for positive integers. 3. Non-integers, like fractions, decimals, or irrational numbers. 4. 0. 0 can be divided by any number, which violates the uniqueness property of prime factorization. Let's summarize what we've learned about prime factorization. 1. Prime factorization breaks down a number into a product of prime numbers. 2. Prime numbers are already in their simplest form, so their prime factorization is just themselves. 3. Composite numbers can be expressed as a product of prime factors. 4. Only positive integers greater than 1 can be prime factorized. Prime factorization is important in many areas of mathematics, including finding greatest common divisors, least common multiples, and in cryptography. Thank you for watching, and I hope you now have a better understanding of prime factorization.